So let me record. Alrighty. So let's get right to it. There's 9 problems. So with number 1, I think was probably the most time consuming. So I wanted to do this one first. So here we go. The function p of x equals negative 0.015x squared plus 1.2x minus 11.5 gives the profit in thousands of dollars when a company sells a new product at X dollars per unit. Which of the following statements best interprets the average rate of change for this function from x equals 50 to x equals 55? Okay, there's a lot going on here. A lot. So first of all, I have this super complicated looking function. This has like everything under the sun. It's got decimals, it's got negatives, it's got an exponent. There's just a lot. And then it's telling me that I need to figure out what is the average rate of change from x equals 50 to x equals 55. Well, you guys tell me, when you see average rate of change, which formula comes to mind? You guys all know this formula. What is the average rate of change formula?
What is the average rate of change formula?
Yep, otherwise known as the slope formula, otherwise known as just the rate of change formula.
Slope intercept?
It's not slope intercept, it's just the slope formula. What's that formula? The rate of change formula. If it asks you what is the slope, what is that formula that you use?
Y1.
What is it?
Y2 to over Y1. And X will take X1.
Yep. Y2 over minus Y1 over X2 minus X1. That's the rate of change formula. Anytime that a question asks you for the rate of change or the slope, that's the formula that you need to use. But in this problem, I know what the formula is, but I don't know the value of y. I only know the value of x. I know my x2 and my x1. So like if I made a little table, I know that it's telling me to look from 50 to 55. So I know my x's, but I do not know what those y values are. So what should I do if I have a function, I have a function equation, what can I do to figure out the value of y?
Input everything.
Yeah, we're going to plug in because remember that these two x values, these are my input values, and I can use those input values to figure out the output value. So what I'm going to do is I'm going to start by plugging in that 50. And remember, let me just rewrite this. Remember that when you have a function, you're going to plug in whatever input you want, you have to plug it in every time that there's an x. So since I'm plugging in 50, I'm going to plug 50 over here, and over there 3 times. Because if you look at the original function equation, it has x as p of x, then it has negative 0.1015x squared, and then 1.2x. There's 3 x's. So you plug in that 50 every single place that you see x. And then from there, we have to evaluate this function. We need to do the math and figure out what you get. So when I do the math, I'm going to always think of PEMDAS. PEMDAS tells me the order in which you can evaluate things. So what do I have to do first?
Exponent.
Good, we're going to do the exponent first. So that means I have to do 50 squared, 50 to the power of 2. What do you get?
2,500.
2,500. That's the first step. And by the way, guys, I didn't mention this before, but please write this down in your notebooks. I want everybody to write it down because writing helps you to remember things. So right now, by writing things down, that's helping you to study, it's helping you to memorize, and it's going to help you when it comes to the mid-year assessment. So write this all down. Okay, so I did 50 to the power of 2. Now, PEM, next step is multiplication. So what should I multiply?
Negative 0.015
Mm-hmm.
2,500.
Okay, and what do we get there?
Negative 37.5.
Negative 37.5. I can also do 1.2 times 50. What do you get?
60.
What did you say?
60.
60. And then that minus 11.5 comes right down because we didn't really do anything with it. Okay, and now I have one last step. I need to do some addition and subtraction. So negative 37.5 plus 60 gives me 22.5. And I'm subtracting 11.5 from that. So my final answer
11.
is 11. So all of this work that I just did tells me that F, or not F, but P of 50 equals 11. Function notation, remember? The parentheses tell me where the input is. So when your input is 50, this was my input, my output was 11. So in my table, I can now fill in the blank. This would be 50, 11. Questions on what I'm doing so far? Questions on any of the math that I did to get to my answer? Like I said before, this is probably the most challenging problem that we're doing today. So make sure that you're asking questions because this is your chance right now or never, to understand. Okay. Question in the chat, do I turn the 11 into thousands? Good question, yeah. So it's telling me that the profit is measured in thousands of dollars, right? In thousands of dollars. So technically the 11 would be 11,000. But we're going to keep it as 11 for now because when we do the math, whatever we end up getting, I know already that I need to think about it as thousands. So you could either do it now or do it later. But yeah, let's do it now. That's a good point. This is technically 11,000. So thank you for that, Lauren. Questions on that? On why that's going to be 1,000? Awesome. Okay. Now I did it for 50. I have to do it for the 55 as well because I need to know both of those input outputs in order to calculate my rate of change. So here we go. Now I did all the work. Does anybody still need a second to write it down or can I erase it? Okay, let me erase it. I'm going to do all the same steps, except now I'm plugging in 55. So calculator's out. We can use a calculator for this. Let's go ahead and do the math. 55 to the power of 2. What do you get?
3,025.
3025. So now I have negative 0.015 times 3025. Okay, multiplying. Negative 0.015. Go ahead, Ajar.
375.
Say that again. Sorry.
Negative 45.375.
All right. And 1.2 times 55?
I'm gonna let someone else answer now.
56.
Thank you.
What was that?
56,
56?
66.
66, okay. Cool, and now 45.375 plus 66.
20.625.
20.625 minus 11.5.
9.125.
9.125. My input was 55. My output was 9.125. And remember, that's going to be by thousands. So what's 9.125 times 1,000?
9,125.
Yep, 9,125. So now I have everything I need. I have my x1, x2, y1, y2. So the final step, I know you guys thought we were done. We're not done yet. The final step is to use the slope formula, the rate of change formula, and plug everything in. So y2 minus y1, that's going to be 9,125 minus 11,000 over 55 minus 50. So go ahead and plug that in and see what you get.
Negative 375.
Negative 375 dollars. And that's our answer. So since it's negative, read the question carefully. Which answer choice is it going to be?
B.
B. Exactly. So, okay, wow, we just spent 16 minutes on that question. And that's how long it takes. You got to put in the work. You can't just click the random answer thinking it's going to work. You got to actually put in the work to figure out what it's going to be. This is one of those questions that you can't really use process of elimination. You can't really try and figure it out logically. You have to do the math. You just have to. All right, so do I have any questions on this one? Okay, cool. Number 2. Another rate of change, but this one's a lot easier because they already give you the table. You don't have to put in all that work. So this one's saying, what is the rate of change between week 1 and week 5? So this is easy. They tell you where to look. So I'm looking at week 1 and week 5, and I'm going to calculate the rate of change using the rate of change formula. Now, when I have a table that's horizontal, which of these is going to be my x values and which of them is my y values?
X is 5 and 1.
So so the number of weeks is the x values, and the number and the price is the y values. So on a horizontal table, it's always x on top and y underneath. And now I just plug everything in. This is 694.99 minus 740.79 all over 5 minus 1. Use your calculators, plug it all in. What do we end up with?
Negative 11.45.
And that's it. So this is like the easy version of question number 1. With problem number 1, we didn't have a nice table or graph. All we had was an equation. So we had to do the work and figure out what the table would look like. So that's when it gets hard. But when they give you the table to start with and you already have those numbers in front of you, it's a piece of cake. You just plug it in to the formula and you're done. All right, so any questions on number 2? Awesome. Remember, keyword is rate of change. So anytime you see rate of change, you know you're going to be using this formula. Number 3, word problems. All right. So when you're given a word problem and it asks you for an equation, we're always going to start off by figuring out which of those numbers, there's always going to be some values, some numbers in that problem, which of them represents the slope and which of them represents the y-intercept. So can I get a volunteer to read this word problem? No? Save my voice, guys. It's going away. I need someone else to
I'll
read
read
for
it.
me. Go ahead.
Jake's Cart Depot,
Depot, like Home Depot.
charges $24 per day to rent a car as well as 0.18 cents per mile driven. Assume that Y represents the total daily cost to rent a car and X represents the number of miles driven. Which of the following equations can be used to calculate the total daily cost of renting a car? Select all that apply.
Cool. Select all that applies. So I know how many at least do I have to have down? At least how many?
2 or more.
Yeah, 2 or more. So I need at least 2. All right, so let's begin. Which one of these numbers, I have a couple of values. I have $24 per day and 18 cents per mile. Well, I see the word per 2 times. So how do I figure out which of those, only one of them is going to be the slope. Which one is it going to be?
The
0.18. Ijara, can you explain how you figured that out? Because I really like the way you did it.
In the world, sorry, not in the world, I mean, the word problem, it already gives you the X and the Y. And it says X represents the number of miles driven. And in the first sentence, it says 18 equals per mile driven.
Good. So we kind of match that up. Since the X is the number of miles and the 18 is also miles, those two go together. Whereas the 24 is days, number of days. So that doesn't match correctly. So I know that the slope is going to be miles. So that's how I know that the 0.18 is my slope, which means that the 24 is my y-intercept. All right. Well, now I can go ahead and I can write my slope-intercept equation, y equals mx plus b. Just plug those numbers in, and you get y equals 0.18x plus 24. So that's step 1, writing it in slope-intercept form, because that's kind of like the easiest, most simple form to write it in. And so that means that I can check off number 3. That's already done. But then I know that I have to do at least 2 because it's select all. So now I want you guys, what you need to do is look at all the answer choices and let's figure out first which ones you can definitely get rid of. So which ones maybe have the X in the wrong place with the wrong number? What can I get rid of?
You can get rid of the 1, 2, 3, 4, 5, the 5th box.
Yeah, Bianca said it as well. We can get rid of number 5 because the X, they put it with the 24 and that's not correct. Where else? Guillermo says number 1 and number 2. Awesome, exactly, because both of these have it with the 24 as well. So that I already know is wrong. And then with the remaining answer choices, let's think, how can I go from this equation? How could I turn it into that equation? What did they do?
They subtracted 24.
Yeah, so I heard that from both Lauren and Najara. We subtract 24 because you can do that. That's fine. That's the subtraction property. When you have an equation, you're allowed to move things around. You can do a little bit of math to move things from one side to the other. If you want it on the left, you can move it to the left. If you want it on the right, you can move it to the right. That's totally fine. So what they did was that they subtracted 24, and then it ended up being on the left side. So this was y minus 24 equals 0.18x. So that's still good. That one works. Questions on how I moved that around? Cool. But then now let's see, is it possible to go from this equation to that one?
No.
What does it look like they did, which is not allowed?
Adding.
You added it together.
Yeah, they were like, oh, I can just combine like terms. And then they were like, okay, 24 plus 0.18, that's 24.18. Boom, done. But what's wrong with that? Why can't you do that?
Because they're not like terms.
They're not like terms. One of them has an x, the other one does not. You can't combine those. So that's also incorrect. So basically with equations, if you follow the rules and you follow them correctly, you can do whatever you want. But as soon as you break a law, break the rules, that is not going to work out for you. Okay, so equations are kind of fun because you can play around with them, you can move them around, you can do different things as long as you're following the rules. Questions on number 3? Awesome. Number 4. Another word problem. All right. Would anyone like to read this one? All right, cool. I'll read it. It's fine. All right. A truck driver travels from a distributor to a retailer every week. The driver records the distance that he is from the retailer at different times during his trip. After several weeks of collecting data, the driver creates a scatter plot of the data. The best fit line is y equals 73.6 minus 67.8x, where x is the number of hours spent driving and y is the distance in miles from the retailer. Which of the following statements is true? Select all that apply. Another select all. Okay, so there's a lot of information, but the most important bit of information is this equation. And then the information that they tell you after that. All right, so don't worry too much. A scatter plot, guys, is basically like, you know, in the real world, things don't work out perfectly. And we'll learn a little bit more about this very soon. This is actually what the next topic 5, is about. But basically, when you measure things in the real world, life doesn't work out perfectly. So you're not always going to get a nice, perfect graph of a straight line that looks like this. More often than not, what's going to happen is, like, this driver collected some data, and his data probably looked something like this. And then he was like, okay, I can draw a line that kind of passes through these points somewhere in the middle. And that's what the best fit line is. That's what he did. He did the best fit line. We're going to learn a little bit more about that. But at the end of the day, long story short, when you make a best fit line, you can write an equation for it. And that's what he did in this scenario. So we have an equation that represents where x is the number of hours. So I might as well just keep this here. So this is hours and y is distance in miles. All right, so we have a little graph. You didn't have to make a graph. I'm a very visual person, so sometimes it helps me. But let's look at this equation. Y equals 73.6 minus 67.8x. Is this in slope-intercept form? Guillermo says yes. Do we agree?
Yeah.
Yeah, it is. It's in slope-intercept form. It's just written a little bit backwards. So if I wanted it to look like y equals mx plus b, how would I rewrite it?
Negative 67.8x plus
Plus
73.6.
Yeah, so we just switch those numbers around. So it's negative 67.8x plus 73.6. Cool. Now it's in slope-intercept form. Now I can identify a couple of things. What do I know?
You already know it's decreasing, so box 2 is checked
Yeah, we know that how do I know it's decreasing?
because of the
Negative.
negative.
Negative, yeah. So my slope is negative 67.8, decreasing. So I can check off box 2 and get rid of box 1. What else do I know?
Box 4.
Box
Yeah,
4.
D.
So box 4 is the distributor is 60 or 73.6 miles away. Good. The 73.6 is my y-intercept.
And
That's
that
my
is and 73.6 represents the distance in miles.
Yeah, the distance. And even more importantly, not just like any distance, which specific distance is it?
The distributor.
Yeah, like when I remember what I always say with y-intercept is always your starting amount. Your starting whatever it's measuring, it's the starting amount. So this is my starting distance. So that's what that one is.
You
This
could
one's
also
out.
check box 5,
And then I can also do box 5 because
the per hour.
yeah, remember that slope is speed. Speed will always be your slope. So since my slope is negative 67.8, that tells me that my speed is negative 67.8. That means this is, what are the units of this slope?
Per hour.
Miles per
And also miles.
hour. Okay, so he starts far away and he comes closer and closer and closer to his final location. So those are my final answers, B, D, and E. Questions on number 4. Awesome. All right, number 5. Another kind of word scenarios. This will definitely come back for the mid-year, so let's just review this because we kind of did this on one day and then we kind of didn't review it after that. But basically, when you read a situation, you have to figure out if it's going to be linear or not linear. And there's a couple of things that we got to look for that would make it not linear. Can anybody remember what those things are? There's 3 that I can think of.
Percentages.
Mm-hmm.
I believe it was subtraction. Was it? No. Okay,
Subtraction's okay.
I need to go back to my
Oh, there's Karina said it. Not subtraction, but multiplication. Multiplication words. So there's a few of them. Like, for example, factor. When you factor something, that has to do with multiplication. And another thing that I can think of is like, sometimes it'll say like, oh, the bacteria cells doubled every hour. So any words like that, like doubled. What's another one? You can double something, you can triple. Any of those words, if it's talking like, if it's growing by multiplication, if it's doubling, tripling, growing by a factor of 5, whatever those words, not linear. Because linear has to add and subtract. It grows by a constant rate. So you can only work with addition and subtraction. So in this case, where are the problems that we see? Where do we see whose situation would not be linear and why? Yeah.
Anne and Julian.
Percent.
Yeah, Anna and Julian.
Anna and Julian.
There we go. But Brian is good. Brian is increasing by $4,000 every year. That means he's adding 4,000 every year. That's fine. And Kendra, the water increases by 2 inches every hour. That means you're adding 2 inches every hour. That's also fine. So for this one, the answer was Brian and Kendra. And that's it. Questions on number 5. Moving right along, number 6. All right, number 6. We did this one actually in class. This one came back on the test, and even though we did it in class. So who wants to walk me through this one? How do I figure out the correct equation? What do I need to find first?
The slope.
Slope. I need to know the slope so that I can figure out the correct answer, because all the answers have the same y-intercept. The only difference between all of them is that slope. So what do I find first to figure out the slope?
The y-intercept.
Okay. And
which is
then?
50. And you need to find 2 points that are like on the lines.
On the line. So 2 perfect points. Exactly. So can anyone tell me one perfect point?
1,180.
Mm-hmm. And another one?
0,150.
0,150. We might as well use that one. Okay. Slope formula. We've done this a couple of times now. Let's go ahead and do it real quick. y2 minus y1. You can either look at the points the way you have them, or you can put them into a table to organize them a little better. But either way, what would I put for my y2?
180.
180. So this would be 180 minus 150 over 1,000 minus 0. What do we get?
0.03.
0.03.
0.03. Now, this was in the non-calculator section, so that was the most challenging bit. But if you do the math and you work it out, this would be 30 over 1,000, which is the same as 3 over 100, if I just knock off those zeros. And 3/100ths is 0.03. That's the hundredths place. Okay, so that was kind of the hardest part of it, is figuring out how to turn that fraction into a decimal without a calculator. Questions on this one? Okay, number 7. Number 7 we also did together one time during class. You have to match the graph to the correct one. Slope is 3. Since the slope is 3, what can I get rid of?
A and D.
Slope man can help you out. I can get rid of A and D, because both of those have a
Negative slope.
negative slope. And I know I need a positive one. Then it's telling me that f of 0 equals 14. When I say f of 0 equals 14, what is that telling me?
Where it passed through the line.
Mm-hmm. So if my input is 0, my output is 14, what is the coordinate point that that refers to?
0,14.
Yeah, this is 0, 14. So it's telling me that it passes through 0, 14. So take a look at these two answer choices. It's a little bit blurry, but you can clearly tell one of them passes through the 14. Which one is it?
B.
B, yeah. This one passes through negative 14. And this one, positive. So we needed the positive one. B is our answer. Questions on number 7.
Wait, so that means you don't always have to look at the y-intercept.
Well, in this case, it was the y-intercept.
Oh, I'm sorry.
They just said it.
Have to look at the x-intercept.
Yeah, right. So in this case, they basically what they told you is that the slope is 3 and the y-intercept is 14. But instead of saying it with words and saying the y-intercept is 14, they gave it to you using function notation. So you had to realize that f of 0, that's the y-intercept. That's what you had to look for. Okay. So that was the little trick that they did. All right, number 8, another one of matching. This time I have an equation written in what form?
Standard.
Standard form. And when you have standard form, what is the number one thing you have to do right away?
Turn it into slope intercept.
Yeah, we're going to convert it because right now it doesn't give me any useful information. I have to turn it into slope intercept form. Because once it's in slope intercept, I can know the slope, I can know the y-intercept, boom, good to go. But right now I don't know anything. So how do I turn this into slope intercept form? What do I do first?
Plus 3x.
On both sides?
Yes, which will give you -12. And you'll have the 5y. Then you divide 5y by -12.
Okay, be very careful though. Can I combine like terms? Can I?
Oh, I messed up.
Oh, that's okay because now we all learned, because I'm sure other people made the same little mistake.
No
Is that,
wonder I got stuck. I didn't add the x.
yeah, you can't combine like terms here because the 15 does not have an x. So we're going to keep these separate. This is 3x
3x
minus
-15.
15. Exactly. We can't combine, keep them separate. But now when you divide, because you do have to divide
Over the whole thing.
over the whole thing, we divide each of those terms individually. So 3 over 5, 3 divided by 5.
It has to stay like that because there's no way to divide.
Yeah.
String.
So we keep it as a fraction. What about the -15 though?
-3.
That's -3. So my final equation is y equals 3/5 x minus 3. What can I do to identify the correct answer?
Since the slope is a positive, we have to take away the negative signs, which that will be A and C.
A and C are out because they are negative. And then what else can I look at?
The y-intercept, which is -3,
Y.
so it is B.
Good. The y-intercept has to be -3, so it has to be B. Okay, that's very much that anytime you have a question like this, it will definitely come up. They love this type of question, but you have to know, okay, standard form, change it to slope intercept, figure out the y-intercept and the slope, boom, 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 cross everything else off, and you are done. Okay, one more question. I have 3 minutes left, so let's finish it real quick. One more matching one, except this time, what form is this one written in? It's that weird one that we don't like. What's it called?
Is it point slope?
Yeah. Thank you, Bianca. You got it too. Point slope. Point slope tells me one important thing. Well, two important things, but which one's the easy one to see?
The points.
So it tells me,
Intercept.
it doesn't tell me the x-intercept, but it does tell me a point on that graph. And there's one more thing that it tells me. It's in the name.
The slope.
The
The
slope.
slope, yeah. So look at that equation.
No, actually, I'm sorry. I said x-intercept. Oh my.
That's okay.
I mean the slope.
Who can remind me which of those numbers is the slope?
The -2.
Good, the -2. So I know that my slope is -2. I can get rid of two answers. Which ones?
I would say B and a C because they're both positives.
Good. These are both positive slopes, so I can get rid of them. Okay, but then I also know a point. This is the tricky part. Who remembers out of the numbers that are left, we already used this -2. What's my point?
-3 is the y.
Y.
Right? Wait, no.
-2 is the Y, right?
There's actually a positive in the parentheses. You have to make that a negative.
There's a
Oh.
So what's the point?
Is
-2, comma 2.
-2,
Comma
3.
three.
Okay, I'm going to show you why very quick. This is y minus y1 equals m times x minus x1. So my y1 was 3 and my x1 was -2 because you got to flip them. That's the tricky part. That's the hardest part of this problem, is that you have to flip the sign. So my point is -2 comma 3, which means between A and D, which one has that point? See if you can check.
A.
Yeah, A has it. -2 comma 3 right here. So tricky, tricky, tricky. This is something I don't know if it'll come back, but it might. So it's worth making sure that you remember how to read this form and identify that point, because that'll give you the right answer. Questions, comments, concerns? We are done. Homework is due tomorrow at midnight. Do not forget to finish it up if you didn't do so today. Have a happy, happy Thanksgiving. Have a good break, you guys. You deserve it. And I will see you when we come back. I am going to post the link on Teams to your optional extra credit packet that you can complete over the weekend. All right. Goodbye, everybody.
Week. Goodbye.
Bye.
See you later,
Yeah, see you later. Bye, guys.